Welcome to another lecture on biostatistics. As indicated, we want to study measures of dispersion, and for now we want to look at standard deviation. So that is what we want to study majorly, but there is also some aspect of quartile deviation here in our study today. Now, introductory aspects of this includes this. The measure of dispersion gives the scattering of the data. It tells the variation of the data from one another and gives a clear idea about the distribution of the data. The main idea about the measure of dispersion is to get to know how the data are spread. Now, if you look at, or if you watch this video to the end, you'll find a linked video talking about range and variance, which we had talked about earlier. So today we want to focus on these other methods of measuring this scattering and dispersion called standard deviation and quartile deviation. Now, going to standard deviation, we're actually talking about a measure of the amount of variation or dispersion of a set of values. A low standard deviation indicates that the values tend to be close to the mean of the set, while a high standard deviation indicates that the values are spread out over a wide range. Now, quickly or mathematically, we can link this standard deviation with variance and declare quickly that standard deviation is actually the square root of variance. So that simply means if you know how to find variance from our previous lecture, you can quickly take the result you obtain and you find the square root and you find standard deviation, which is a very important measure of dispersion. Now, trying to bring in the formula that is used for ungrouped data, that's just a set of data which can be ordered as entries. This is the formula that applies. In other words, you first find the mean of the data, then you get the difference between each entry and the mean. You create a column for that, then get the squares of the results you will obtain. The summation of those squares will give you this numerator part. Divide by n, which is the number of entries. Then once that is obtained, the square root of the result will give you standard deviation. Similarly, when we are talking about ungrouped data, then when you're talking about, this is now grouped data, grouped data. When you're talking about grouped data, you will have to find the midpoint. So instead of using entries, we are now going to look for midpoint values, or the mid values for the various classes. Then also you get the mean of that the data, so you know the procedure for finding mean as well. Then the difference between the mean and the midpoint, the square of that. Then you find a column for the product of the corresponding class frequencies and the result you have obtained from the squares. And then you get the summation of that, divide by the total frequency, which is given by summation of f. Then the result is put under root and we find standard deviation. So I think this is for, as I've said, for grouped data, and this is for ungrouped. Okay, so we get to an example to better understand the formula we've just given. So determine the standard deviation of the grouped data given. So this is the example of a grouped data. If you are following our lectures, you will find something similar to this in the previous lectures. So we are given classes here, and we find the corresponding frequencies given column here. So our work is to go to solving this quickly. The formula that controls us is this, because we are talking about group data. So this is similar to what I just gave you a few minutes ago. So we want to first look at the columns that are going to help us in finding this result. So first of all, we know we have the classes, okay, and we have the frequencies, and directly we can sum up this even in Excel, and we find the summation of f as 48 here. Our next step is to find the midpoint, and this is obtained by simply summing this and divide it by 2, and you will obtain this. Followed by the next class, you also do the same thing, and so on and so forth up to the last class, where you take 23.4 plus 23 divided by 2, you'll get 23.2. So that is for the midpoint. That's what will act as our x in this formula here. Then we get to the product of the corresponding frequency of the classes and the midpoint. That is a very important column for finding the mean, because remember, we will need this mean to solve or find out for variance and for standard deviation. So for f of f times x, that will simply be the x we have here, 20.7 times the corresponding f, which is 3 in this case, you get 62.1. 10 times 21.2, you get 212. 11 times 21.7, you get 238.7, etc. The next step is to now find the mean and the difference between the midpoint and the corresponding the value of mean which we have just found. So let's see what happens. How do we get mean? Summation of f of x over summation of f. Just this divided by this, you get 21.912. So our column here will be obtained by take the value for midpoint 20.7 minus 21.919. You'll find something like this. Do for 21.2 minus this, you get this other one. 21.7 minus mean, you find this up to the end. Okay. After that, we now square what we have found in this column. That's very easy. Just take this value and square it. Apparently you will see even the negative values are turning into positive because of simple rules of squaring numbers. So this is basically going to give us this value. So negative 1.219 squared gives us this. This we find for squaring negative 0.719, and you find that up to the end. So that is fine and can quickly be obtained. After we have found these squares, remember our formula demands that the squares must be multiplied by the corresponding frequency of the classes. So I will take this, multiply by f. So in this case we'll take 1.485352 times 3, you get 4.456055. Then the next thing is multiply this and 10, you'll find this. Multiply 0.047852 by 11, you find this, and so on and so forth. So that means we shall already have obtained a column for f into x minus x bar squared. Okay. So once that is obtained, then we need to get the summation of what we find in this column, and that will give us the numerator of this formula. So we quickly substitute that and then find divide by the summation of f, which is just here 48. When that is done, then the next thing is just get the square root of that. Before you find the square root, whatever we shall find before that square root or finding the root of the result is what we call variance. So the root of that will give us standard deviation, which is just 0.64474. You can try this question and verify your result with what we have shared here. It's good for practice. Now let's say something about quartile deviation. Quartiles usually divide set of data into 4 parts. For group data, an ogive may be used to obtain the quartile values. That is something which you can clearly obtain if you have drawn that ogive, as we had already indicated in earlier lectures. You look for that point where the value that corresponds to a quarter of cumulative frequency will give you first quartile. Then the half of cumulative frequency will give you the second quartile value, and 3/4 of cumulative frequency will give you the third quartile or the upper quartile, and so on and so forth. So that is related to what we find when you do ogive analysis of these quartile values. For sorted data, if your data is sorted, then you'll first find the first quartile by taking the number of entries plus 1 divided by 4, and that will give you the first quartile entry. Okay, so n plus 1, where n is the number of entries, divided by 4 will give you approximately the location or the value of the first quartile entry. The second quartile entry is obtained by doing 2 over 4 of what we find by summing the total entries plus 1. So that is 2 into n plus 1 over 4. The third quartile, or what others call upper quartile, is 3/4 of the n plus 1, where n is the number of entries we have in the sorted data. Remember, the data need to be sorted. That is very important. So don't ignore this if you're talking about individual entries which are not grouped. Now, something important here is the fact that interquartile range is obtained by getting the difference between the third quartile, or what other people call upper quartile, and the first quartile, or the lower quartile. The second quartile is equivalent to median of the data. This is an announcement. You need to know this. The second quartile is equivalent to the median of the data. Remember it. Thank you. Let's get to the concept of quartile deviation, which is also used as a measure of dispersion. So the quartile deviation, QD, is the outcome of half of the difference between the upper and the lower quartiles. So mathematically, this is what is obtained. QD is equal to Q3 minus Q1 over 2. This is just upper quartile minus lower quartile divided by 2. And this gives us what we call quartile deviation. And it is the absolute measure of dispersion. But when you talk about relative measure of dispersion corresponding to QD, we talk about coefficient of quartile deviation, which is discussed in this slide here. Coefficient of quartile deviation is actually the outcome of what we find when we operate this formula Q3 minus Q1 over Q2 plus Q1. And by now I hope you know what we mean by Q3, Q1, Q3, Q1, and CQD. CQD is just but coefficient of quartile deviation. So this is the upper quartile minus the lower quartile over upper quartile plus the lower quartile. It is used to study and compare the degree of variation in different situations. So we can apply this for this still measure of dispersion as a coefficient. Now, something to note: just as quartiles divide set of data into 4, deciles divides it into 10, and percentiles divides it into 100 parts, or parts of 100. So you need to know the trend. Remember, when we were operating our value, we were trying to explain what we mean by upper quartile, lower quartile. There was a constant use of 4, and that actually indicates to us that we are dividing our set of data into 4. When you're dealing with deciles, then you need to change that 4 to 10, and when you're talking about percent or percentiles, it is always over 100. Thank you. Our next study will be on ratio, rates, and proportions. Remember to subscribe, as our custom is. Thank you.